We're going to talk about how to restructure and refactor code today, but before we do that, I'd like to introduce myself a bit. My name is Ola. I'm really a developer by heart. I love to code, and I love to code so much. So back in 2000 or 2001, I was in this project where we were having troubles to deliver to our customer, and we knew we needed to do something. So a guy at my team, he picked up a book called Extreme Programming, and he said, this is crazy stuff. We need to try this. So we did try a lot of the practices from Extreme Programming. We learned a lot, and at the end of that project, we were delivering features to our customers like we never did before. So at that time, I was a consultant, and my next project, we didn't have all these. Well, my colleagues there, they didn't know a lot about extreme programming, so I ended up teaching people about extreme programming that I learned from my previous project. So in a way, I became an XP coach or Agile coach or whatever. But I only did that because I wanted them to learn how to deliver software so I could program more. But it got me sort of interested in business. It made me think. So if there's a big difference between how you develop software, if you can deliver faster by changing your process just a little, then there is a big win here. So I continued to do some XP coaching, Agile coaching, but now I don't have to do that anymore because a lot of the customers that I come to, they know what Agile is, so I don't have to explain stuff anymore. So I'm back to coding now, which I really like. Before we dive into this topic of the day, I would like to share a story with you. It's about my kids. I have 3 kids, a 6-year-old, a 9-year-old, and a 12-year-old. And the oldest, he's a boy, and he said to me one day, well, in a parent's life, there comes this dreaded moment where at a certain point, your son becomes old enough and asks you this dreaded question. Like, what do you do for a living, Dad? And I was somewhat prepared, so I said to him, well, I program, I create computer software. And he looked at me like a dog that you've shown a card trick. Like, what's a computer program? What's software? So I was thinking, oh, okay, so he has this Nintendo Wii where you can. And he has this FIFA football game. So I said, okay, so FIFA, that's the football game, the soccer game, that's software. It's a computer program. He looked at me, he's like, really? Yeah. Can you make me a game? Maybe I could, but yeah, Dad, make me a game. Oh, okay, so I thought a while, and then I said, okay, I'll try to make you a game. Give me 30 minutes. So he went off, and after 30 minutes, I created a game. It was a really simple game. You just press the button, and it says, you win. So I called him over, and I said, Alexander, come over here. I've made you a game. And he said, okay. So how do I play? Okay, press the button. And he did. And it says, you win. It's like, yes! And then he said, okay, now what? Well, I played again. Said, you win. It's like, yeah, I'm good at this. And then after like five games played, he was like, Dad, this is boring. I win all the time. Like, isn't that what you want to do? No, 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 no. I need a challenge. I need something else. Like, okay. So give me a couple of minutes. I'll do something. So I did what most programmers do. I threw in an if statement. So every other time you played, you lost, and then you win, and then you lose, and then you win, then you lose. Like, called him over again. It's like, Alexander, okay, so try the game now. And he pressed the button and said, you win. I was like, Dad, it's the same game. No, it's not. No. And he played again, and he lost. And it's like, oh, damn it. I lost. I don't want to play this boring game. Well, you need to try it one more time. And he pressed the button again and said, win. It's like, yeah. And then he lost, and then he paused for a moment, like, called his younger brother, Maximilian, come over here. Dad made us a game. And his younger brother is like, okay, so how do you play this? Oh, you press this button, and it's really easy. It's like, you win. And his younger brother reaches over, and he pressed the button and says, you lose. So Alexander wins, Maximilian loses. It's like, oh, really frustrated. So Alexander reaches over again, pressed the button and says, he wins. And his younger brother reaches over, it's like, he loses. And he's really frustrated, and a couple of minutes later, they figure it out. They lose it every other time and win each other every other time. So I like to experiment with my kids a lot. So, but really, what I'm really trying to say with software isn't really that easy to change at any point. We learned about feature toggling previously here, but sometimes getting to being able to toggle a feature is really the hard part, and it's that hard part of getting to changeable software, because frankly, every system that I've programmed on, or every code base that I've been looking at, it's more or less of a mess. Some parts are kind of good, but there's always a messy corner. And at one point or another, someone or something tells you that you need to go into that messy corner. And when you need to go into that messy corner, you start calling it names like legacy code and who wrote this crap and stuff like that. But a colleague and I, we came up with a method that I would like to show you today. We call it the Mikado Method, or we use this to behead the legacy beast. Because have you ever been in a code base where you change one thing and something else breaks? It's like the old Greek story where you cut off the head of a hydra and 3 more pops out, and you cut the head off and 3 more pops out. I've seen a lot of systems like that. So I would like to tell you a story where my clicker worked. Me and a friend, actually Daniel, who I came up with this method with, we were in a project where we were working on a defense system for airplanes in Sweden, and this sales guy came in one day and he said, we made another sale. And everyone was like, yay! And then we looked at the code that we needed to change, and the happy face just vanished. So we needed to do that change. Me and Daniel started doing that change, and we started changing stuff, and after a week, we had 500 files checked out. After another week, we had 1,000 files checked out, and we were using ClearCase at that time. That is really painful. But ClearCase had this stupid feature where you could lock files. You can lock them for change. So we started locking files, and we said to the other developers, "Don't touch this." And after 3 weeks. Almost 15 days of working, we had close to 1,200 files checked out. And the system wasn't compiling, so we couldn't run the test, we couldn't even run unit tests, we couldn't do anything. So Daniel called me up one day and he said, Ola, you know what we have to do. And I said, yeah. And that was one really tough weekend because I kept thinking about how we needed to just throw all the changes away. So Monday morning, when we faced the team on our regular morning meetings, we said to the team, so guys, you know that the change that we've been working on for 15 days, and you see all the faces light up, like, yeah, they're going to be done today. No, we need to like trash that. We need to throw that away because we can never finish it. And that was one of the toughest meetings that I've ever been to. But I guess the moral of this story is that it's never too late to turn back. So let's say that we had this system. We were trying to make a change. And we got some errors. I guess if you're used to Eclipse or IntelliJ, you know all these compiler errors or .NET you get when you change something. And then if you change, patching those errors leads to more errors. Like it's the Hydra. And patching that led to more errors. And each patch led to even more errors. So this is us like having 1,200 files checked out. And in the end, we were trying to stop a shockwave with our hands. So when we realized that, we could only revert that. So we started again from scratch, but we knew that we needed to do that change. So we started again, and I think the definition of insanity is trying the same thing over and over again. But we did something. We did an adjustment here. We tried the same change, and this time, instead of forging ahead and trying to do the change even harder, we wrote down the compiler errors on a piece of paper as a prerequisite, like something you need to do in order to make the other change. And then the really non-intuitive step, we kept the notes, but we reverted earlier this time. So we knew something about the system. And then we started implementing the prerequisites. We tried one of the prerequisites. Oh, and of course that led to some errors. So we noted them down as a prerequisite as well. And then we reverted again. But we had more information. We had started to building a sort of a restructuring or refactoring map. And then we tried to change a prerequisite, and it worked. It didn't lead to more errors. And now we realized, okay, so this is something that we can do. So we did that. And then we tried another prerequisite, and it worked as well. And of course, if those prerequisites work, let's try the prerequisite. And then we worked our way backwards to the original goal by implementing the prerequisites. And this time, we didn't have 1,200 files checked out. We had a lot of files checked out, but we could check them in and then build upon that working change all the time. And finally, the last thing we did was really easy to do. So, after we've been using this method for a long time now, and we've come up with rules or regulations, more like a way of working than rules, really. So So we always start by writing down the goal. So this is the big goal, what we want to achieve. We want to, for this airplane defense system, it was really separating sensitive information from one part of the application so we could deliver it to 2 separate customers. And then we're being very, very naive or very straightforward. We just try to do the change. But instead of building upon broken code all the time, you then revert the broken code so you get back to a working state. And then you're being naive again and very straightforward and try a really simple change. And then when you have the big restructuring map, you fix the prerequisite recursively from the very end of the graph. We call them leaves. The changes that are really easy to do at the edge of the graph, the fringe. We start there and then we work ourselves from the out and in. So this way of working has a lot of benefits, we think. We can always deliver from the main branch. We don't have to have a refactoring branch that lives on and on and on. Sometimes we mess up and we still do that. At the moment I have this refactoring branch that has been living for over a couple of months, and I'm pretty sure by now I won't ever merge that. Because when you branch, that just goes in one direction, and the code goes in a different direction. And if you're really good, and if you're really fast at delivering code, that branch just goes way off, and there's no way you can merge that back. But if you do small changes and check them in regularly, you can always deliver from the main branch. You don't have to have a branching strategy, really. Well, your strategy could be, don't branch for more than 10 minutes. And if you start, and if you are being very straightforward or naive and try something, you do the immediate thing that you need to focus on in order to get the goal, in order to implement the goal. So you have the goal focus, and then you try to do something that will lead to that goal being implemented. Which means that you only do the necessary thing to implement the goal. And the prerequisites, they all also have something that is very necessary. So you don't do anything that's not necessary to reach the goal. In fact, when you have your restructuring map, that is a complete set of actions that you need to perform in order to get to your goal. And if you do this, you have a sort of a memo. You can start your refactoring or your restructuring on the Thursday and start explore the map. And when you leave Friday evening, Friday afternoon, go home, and then after the weekend, you come back and you look at your map. It's like loading a save game into your mind. You immediately get back to a position where you were. Or it's like TDD, where you leave a broken test case. You pick it up immediately and know, okay, so this is where I was. And if you use this in a team setting, I'll show you this later, you can write on the whiteboard. And if you write on a whiteboard, your teammates, they'll know what you're doing, and they'll be curious and say, so what's Ola doing here? What's he doing to the code here? And you point at the code, it's like, okay, I'm doing this. Oh, okay, then I won't do that because that will like mess up your code. So if I do it like this instead, I'll help you. So you can really ease cooperation if you have a big restructuring map that you can look at. So we call this the Mikado Method. Mikado is the name or the brand of a pick-up sticks game. Mikado means emperor in Japanese, I think. And it's the highest scoring stick of the game. I think you know what do you have what do you call a pick-up sticks game here? Okay. So you have a pick-up sticks game here. Yeah. So at the bottom of the pile lies the Mikado. Or in software development, the highest scoring stick is always at the bottom of the pile. It's what you're trying to reach, the goal. And the Mikado method is about finding which way to pull the easy sticks, the topmost stick. You can only pull the topmost stick because you can't interrupt the pile, because then the turn goes over to your opponent, which means you lose. So you have to figure out in which order to pick up the sticks, not disturb the code base, and to win the refactoring game. So the Mikado method really is about finding out the map to the goal, to the highest scoring stick. And I bet by now, most of you are thinking, now where's the code? Is he going to show us some code? Yes, I will. So if you imagine yourself, we're at this small software shop somewhere in the world, Pasta Incorporated. They're really good at creating systems. They have this little program, and we're looking at the application architecture here. It has a launcher. The launcher launches an app. The app uses a UI. And the UI uses a very simple file database. And if you look closely, there's a dependency arrow going in both directions. And we know that circular dependencies aren't good. Keep that in mind as we go through this. So we're going to refactor this. And our idea here is to make an abstraction for this file database that writes file to the file system, because we want to be able to test that system a bit faster. And we want the system to be able to work on my machine and your machine and everyone's machine. So you don't say like, oh, it works on my machine when someone whips up and tries to test stuff. So let's see here. Is that font big enough for you guys? No? Let's see here. Let's try 16 then. Better? Okay, good. Let's take it from the top here. This is the launcher. And when you run this, it doesn't work. But if you run this, it's worked. So this is a really complicated program here. If we want to log in, we press login, and you can see down at the bottom there it says logging in. That's how we know that it works. This is like most of the customers that I visit. That's how they know the program works. They run it. They don't have any tests. We don't have any tests here either. We're going to try to do this without tests. And this, when you click cancel, the application quits. So the launcher here uses an app, and the app is launched. When the app is launched, it shows the login screen, and the login screen loads users from the database. This is pretty much the meat of the whole application. So I'm going to do something really straightforward here. I want to refactor this. I want to encapsulate this. So I'll start with my goal here, and I'll write encapsulate file DB. And I always double circle my goals, because after 2 weeks, that goal is really hard to find when there's 50 other bubbles there. So I want to encapsulate the file DB in order to do testing faster, in order to make it configurable. So how do I do that? Encapsulation means abstractions. And if I want to create an abstraction, I'll try to make in this case, I'll create an interface. So I just change file DB to database, and we'll assume that database is an interface later. And something interesting happens here. So set store is called. That doesn't sound like business logic to me, but this does. So database load users. I think I want to pull up load to that interface, and I want to get rid of the set store because I don't want it to be tied to a specific implementation. So I've learned something here, and I'm going to write that down. I'm going to replace file DB with database interface. So I add a bubble here. And I also want to use the DB interface in the UI class. But I don't think that's enough. I also need to, of course, create the DB interface. And then I want to configure the file in the file DB constructor. So by changing only one thing, I've learned this much. So now the non-intuitive step, revert. If this was a bigger code base, maybe 20 or 30 files would have been changed, and I would have used git checkout or git reset minus hard or something like that. But this time I revert. And then I take a look at my graph, and then I see at the end there that I see two leaves. I could configure the file in the file DB constructor, or I could create the database interface. I'll start by creating the database interface here. Actually, I won't do it like that. I'm going to go to this one and extract interface and the load method. And now I see that the set store method, I don't want that on my interface. I could have the store method though, but that's not the goal of this refactoring here. So I'll just extract the interface database. And now it should be, if I change this, I see that the set store method here is still called, but I don't want to use that. So I want to configure, well, sorry. I've actually already achieved this one. But if I want to replace the file DB with database, I also need to configure the file in the file DB constructor in order to be able to use the DB interface in the UI class. So this is now the only thing that I can do. This has a prerequisite, this has a prerequisite. This is the only leaf I have. Yes?
So it looks like one leaf is done, but we have broken our...
Yes. So that's not okay. So let's revert. Thank you. So we want to replace this one. So we want the get storage file here instead. So we inject the storage file here. Now I could revert here as well, but now I instead create the constructor with the file DB. And nothing is broken, but I also need to use that storage file. So I assign the parameter to file. Yes, thank you. I did rehearse this, but I forgot it anyway. It's a good thing to have a pair programmer right in front of you. So nothing is broken here. And now we need to make sure that this still works, which in our case means we run the program. And we press login, and we see at the bottom there we're logging in. Okay, so this works. So now we've completed our second leaf here, and now we can see if we can use the database interface in the class, in the UI class. Let's see what happens. Okay, but now we don't need this method. So we just remove it. And then we try it again. And it still works. So we're now using the database interface in the UI class, and we want to replace the file DB with the database. But have we really encapsulated the file DB? No, because we need to be able to send in the file database to the UI class, which means that we probably want that to come through the constructor of the UI class. So inject DB into UI. So we can configure our unit tests or whatever to be really fast. And we want that to be but we want that to be a database. Let's go to app and see what happens. I think we need to import that. Okay, so does this still work? If I was doing this on a bigger project, I would probably revert here and write down more. But now this still works, and we're logging in and it works. And also, if we really want to be able to control this, we need to pull out the file DB to the launch method. And now we can try that as well. We want this to be database as well. And now the launcher doesn't work. But I think we just need to So now we see that this set storage file, that's only called from one place, and the store path, let's see if someone uses the get storage file. Well, that's get storage file is only used here. Maybe we can just use this instead. Yeah, that still works. So let's see if we use the get storage file. No, we don't. So now we can remove that, and we don't use the set storage file either. So you can remove that, and this as well. And that still works. So I would say that now we've injected the DB into the UI and we've encapsulated file DB. And we can check that off. So did you notice that we had the circular dependency there between the UI and the app, where the set storage file was used, and then we used the UI again, and how that circular dependency just disappeared when you introduced an encapsulation. You could get rid of that. So this is a very small system. But I think maybe I was really clear. But do you have any questions? Yes.
Is it enough for big changes to handle these required prerequisites on the whiteboard? Is there any application to manage those with some links to files?
So is the question, is the whiteboard big enough?
Basically, yes.
It depends on how big your whiteboard is. No, but it's a really good question, because is the whiteboard big enough? Well, if we were going to be this detailed the whole time, it wouldn't be big enough. When we did the big change with 1,200 files checked out, we had, it was a bit higher, but then we wrote on the back as well. And it had wheels, so we can roll that around and show that to other developers. So we're here now. Now we're there. So what we found out was that a change like this would be only one bubble. Because I think most of us in here, given that we're pretty awake and it's before lunch, but we can fit this in our heads. Most of us can. I can't. But so what we do is we talk about this as granularity. How granular do you want to be? And you can have mixed granularities on the whiteboard. Like some stuff that you know really well could be just encapsulate file DB. And then you know what you need to do. But at some other points, you need to be really, really detailed and say, okay, so we want to fix it like this and like that. And then you spread out. My favorite tool is a whiteboard, so you can erase and go back and forth. And I think there was another question hidden there. Is there a tool? I think you can use, I've seen guys use Excel. Why would anyone want to use Excel, I think? But he managed to create a graph in the Excel document, in the spreadsheet. I would have used PowerPoint or maybe a Google presentation, the equivalent in Google Docs. And then you can share it with a non-co-located teams, a co-located team. And now I forgot the tool. I think it's called GraphViz. Do you know GraphViz? You can create graphs from text files, and you can have dependencies. And the cool thing about this is that you can check in a really small text file, and then you can reproduce the graph on a different computer. So this works if your team is distributed as well. And you can check in the text file, the graph is text file with the code, so everyone knows what you need to do. Yes.
Thank you.
Okay, so if I understood it right, you propose to make all the changes in the main branch, right?
Yep.
Okay, so let's consider a situation. So you are doing your changes, you are committing them, right, in order to get working software. And at some point you decide that you want to do this change in different way.
Mm-hmm.
So what would you do? Would you roll back to some starting point? What if your team members already saw those changes and start using them? So what's
Yeah,
the
okay.
approach?
So I think the question is, if you start to do one change and then you realize there's a better way to do it, would I roll back to a previous point? No, I wouldn't, because I would like take the code back in that direction. Maybe modifying the graph slightly, but the code is still working, it's doing its job, and since I came up with this better idea, I think it's going to be a really fast way there. So I wouldn't roll back. I would try to shift perspective. I would try to transform the code from this working state to that working state, and then go in that direction in very small steps. So usually you don't get very far into a path where, oh, this wasn't what I wanted. You don't get that far. But the good thing is, if you're trying stuff, you're learning stuff. And for me, I learn more when I try stuff and see how that works in reality, which is a good idea for me. Some people, they can analyze their way through a refactoring. I can't. I think there was, yeah.
What about step length, duration? Should it be 1 day, or it can be 1 week or more?
Oh, okay. So
what if we cannot divide one step into smallest?
So is the question, how big should a bubble be, or how long should the graph span?
How big can it be?
Oh, okay. It can be really big. I'm doing this I have this not so detailed graph in my head, and partly on a whiteboard now. It's been living there for months. So.
And how long was single step?
One single step?
Yeah.
One bubble? I'd say that should be 10 minutes. 10-minute change. I like that. I like small contained changes, and I like to do them a lot and then check in. We're sort of running out of time, so please grab me in the hallways later. But when you do this, you tend to want to break down the changes so the refactoring becomes boring. It should be so safe, so it's boring. Yes. Was that an answer to your question? Maybe not.
Sorry, to continue the previous question, what about the costs? Sometimes you have to do some extra work to check your changes. For example, if you have some distributed system, you need to set up something, or if you do a 10-minute change and you have to spend half an hour to check it, I think it doesn't work.
Yeah, I think it's what happens is it really stresses the point how fast you can get feedback from your system, and accurate feedback. So what you realize is that you have a system that is really clunky to set up and really hard to try out. You need a way to get feedback faster. Maybe you want to introduce a test that tests your area, but in order to do that, you need to modify something first. So you're stuck between a rock and a hard place. There's a good book. I suggest you read by Michael Feathers, Working Effectively with Legacy Code. That can get you that seam, get in a test there. But some of the changes you really need to make without having the safety net of a test. But make them as small as possible. So cover, then modify, and try to create a test which is really, really fast.
Well, I have a question. You have one main goal and prerequisites. While implementing each of prerequisites, you get some value. And you hope that at the end, some of that value will fulfill your goal. But sometimes it's not like this. For example, performance or security or other issues that are always aggregate. What you do if at the end you got wrong result?
So I think your question is, so some goals you have, you have the feeling that you can work on them infinite amount of time? No? That was not the question.
I mean, there's sometimes you need to, you can get result only when all will be implemented.
Okay.
You can't know at the middle stage that your performance will be good.
Yeah.
So question is, you make all graph and you still have no result. How you beat with this problem?
I don't know.
This is bad.
So if you have sort of an assumption that this will fix your problem, but it didn't, I don't know. I'll do another graph, probably. Try it again. But sometimes you do get value out of a certain part by just doing. We found that the big refactoring that we did, we realized halfway through that when we did like 30% of it, we still got really big value out of it. Okay, so we're out of time. Grab me in the hallway. Thanks very much.